Hi, welcome to another edition of Engineering with Lego Bricks and Robolab. I'm Eric Wong, and I'll be your host. Okay, let's look at nested forks now. So remember, a fork allows you to do one of two things, turn left or turn right. What if you want to do more than two things? In this case, 3 or 4 or 5 or 6. Well, we're going to use a technique called nested forks. And here I'm going to make a little musical instrument. So I'm going to go in here, I'm going to say, okay, if basically what I want to do is I want to play one of 3 notes, depending on what combination of touch sensors is pushed. So I can come in here and say, okay, if touch sensor number 2 is not pushed, I'll play a C, and if it is pushed, I'll play a D. And I'm going to merge that fork there, so I'll get my little merged forks. Okay, that takes care of 2 of the conditions. And then I'll go in here and say, I'll put another one here, get that to auto wire, and I'll say if touch sensor 1 is pushed, then I'll play an E. And then I'll merge my forks here, trying to make this nice and clean. Now that basically does what we want it to do. So if you read this program, if touch sensor 1 is pushed, I play an E. If touch sensor 1 is not pushed and touch sensor 2 is pushed, then I'll play a D. And if neither is pushed, I play a C. So I can play one of 3 notes based on combinations. But of course we know from simple combinatorial analysis that with 2 touch sensors I can actually get 4 combinations. Both pushed, one pushed, the other pushed, or both not pushed. And that would actually make sense for an instrument. This instrument could not be silent as it is. If neither touch sensor is pushed, it plays a C. It also doesn't take advantage of both of them being pushed at the same time. Because if one is pushed, if touch sensor 1 is pushed, there's no checking to see whether touch sensor 2 is also pushed. So I'm actually losing some of my ability because I'm not taking advantage of this. So I'm going to go ahead and delete some of these things, and we're going to go in and add another little, do a little control V to this thing. I'm going to add in a 4th condition. Actually, I think will make a little more sense. I'm going to move the C down to the bottom here. So I'll use this thing here, and I'll basically use this same thing again. I come in here and I'll say, all right, now what I'm going to do is check for combinations. I got to do a little merge fork here, and bear with me a little patience. All right, now I think I've got a program which captures. Whoops, must have done a bad wire there. Now I think I've got a program which captures the design intent more carefully. Oops, I got to do one more thing. Wire that guy into there. Captures my design intent. So now we say if touch sensor 1 is not pushed and touch sensor 2 is not pushed, that means neither is pushed. Silence. Nothing is played. That's one condition. If only touch sensor 2 is pushed, that's this case. 1 is not pushed, 2 is pushed. I play D. So 1 is pushed, but not the other. I play D. So now we're saying if touch sensor 1 is pushed and 2 is not pushed, I play a C. It's the 3rd condition. So the first one is neither pushed. This is 2 is pushed. 1 is pushed. And finally, if touch sensor 1 is pushed and touch sensor 2 is pushed, then I play an E. So now I get all 4 conditions, including silence when no buttons are pushed. And this makes a nice little musical instrument. You can try this. So this is called a nested fork because there's a forks are within a fork. So I have this main fork here, which consists of this guy and this end fork. That's the main fork. And I have 2 inner forks here, which are these 2 guys. So one there, and then this guy here. So that's an inner fork here, 1 inner fork there, and 1 inner fork there. So 4 different conditions using nested forks. And that's the way you typically would use nested forks.